Hello student. Now today we are going to see the next topic from the unit number 5 is right circular cylinder. Okay. So let us see what is right circular cylinder. So this is the diagram for right circular cylinder. Here we are having two lines. This line is called as the axis and this line is called as the generator. Now the axis line that we are having is fixed and the generator line that we are having that is rotating about the x-axis by keeping this distance fixed. Okay, so while rotating the generator around the axis, we are keeping the distance between the axis and the generator fixed. That distance is called as the radius, and that is called as the radius of the cylinder. Okay, now the guiding curve that you are going to get over here, if you keep the distance fixed, that guiding curve is always a circle. Okay, so next is just now basically while solving the problems of cylinder, what you need is the radius of the cylinder. Okay, so most of the time the radius will be given to you. If it is not, we'll try to find out the radius of the cylinder first. Okay, so let us see how to solve the examples on right circular cylinder. Now if you look at this problem, what we are having in this problem, find the equation of right circular cylinder of radius 2 and axis is x minus 1 upon 2 equal to y minus 2 upon 1 equal to z minus 3 upon 2. Okay. Now to get the equation of the right circular cylinder, what we are going to do, we are going to take P as one point on the right circular cylinder. Okay. Then A123 is one point on the axis. Okay, this you can easily identify with the help of this. So here this is the point 1 2 3. With the help of the equation of the axis, you can see x minus 1 upon 2 equal to y minus 2 upon 1 is equal to z minus 3 upon 2. So the term that you are having in the numerator, x minus 1, y minus 2 and z minus 3, it will give you that 1 2 3 is the point on that line. So we are taking that A123 is one point on the line. Okay. Then the radius of the cylinder is given. So here the length of the radius is 2, which is given to us. Okay. Now if you look at this triangle PMA, this is a right angle triangle. And to get the equation of the right circular cylinder, we are going to make use of this triangle. All of you know that by Pythagoras theorem, you are going to get that PA square is equal to PM square plus MA square. So we are going to make use of this. But see, we are not going to make use of Pythagoras theorem to find out the third side. But what we are going to do, we are going to find out all the three sides. Okay, PA, PM and MA. And then we are going to put the values of that in a Pythagoras theorem to get the equation of the right circular cylinder. Okay. So we know that AP square is equal to PM square plus AM square, that is by Pythagoras theorem. PM is given, PM is equal to 2 because we know that the radius of the cylinder is 2. Now AP square, how we are going to find out AP square? So we know the coordinates of A, we know the coordinates of P. So by using distance formula, we are going to find out AP. And when you take the square root will be removed and you are going to have AP square is equal to x minus 1 square plus y minus 2 square plus z minus 3 square. This is by distance formula. Okay. Now this is a very important thing, AM, that you are supposed to remember. So AM is nothing but what? It's a projection of AP on the axis. So here you have to remember two things. Now since it is a projection of AP, what you have to do? You have to find out the direction ratios of the AP. So how to get the direction ratios of AP? We know the coordinates of A, we know the coordinates of B. Simply subtract x2 minus x1, y2 minus y1, z2 minus z1. You will get the drs of AP. And the another thing, since we are taking the projection on the axis, you have to find out the direction cosines of the axis. Now how to get the direction cosines? If you know the direction ratios, I hope you remember, if you have ABC are the direction ratios. How to get the direction cosines? A upon root of A square plus B square plus C square, B upon root of A square plus B square plus C square, and C upon root of A square plus B square plus C square. So we know here the direction ratios of the axis as 2, 1 and 2. So with the help of that, you can easily find out the direction cosines. So direction cosines will be what? 2 upon root of 2 square plus 1 square plus 2 square. So it will be 9, and the square root of 9 is 3. So it will be 2 by 3, 1 by 3, 2 by 3. These are the direction cosines. So this is the important part. While taking the projection, what you have to do is take the direction cosine, that is 2 by 3, 1 by 3, 2 by 3, and multiply it by the direction ratios of the AP. Okay, so direction cosines of the axis and direction ratios of the AP. Take the product of it and add it. Okay, that will give you your AM. Okay, so AM will look like this. Now once you have this AP, PM and AM, put all these values in the Pythagoras theorem, that is AP square is equal to PM square plus AM square. And when you simplify it by cross multiplying and taking the square and all, you are going to get the equation of the right circular cylinder. The problem is very simple. What you have to concentrate on? You have to concentrate on that triangle. Okay, and in that triangle try to find out all the three sides, AP, PM and AM. AP by using Pythagoras theorem, PM is radius of the cylinder, and MA is by using the projection formula. Now once you have all these three, put it in the Pythagoras theorem, you will get the equation. I hope you are getting this problem. Now we are going to see the next example where the radius is not given to you. Now if the radius is not given, how to find out the radius of the cylinder? So if you look at the second problem, find the equation of right circular cylinder which passes through the section of the sphere x square plus y square plus z square equal to 25. So this is a standard sphere whose center is 0, 0, 0 and whose radius is 5. And this is the x plus 2y plus 2z is equal to 0. This is the equation of the plane, okay, whose 1 to 2 are nothing but what? They are the drs of the normal to that plane. This thing we have seen in the first part of this unit. So please revise that. Okay. So if you have ax plus by plus cz plus d is the equation of the plane, then ABC are nothing but the drs of the normal to that plane. So here 1 to 3, 1 to 2 are the drs of the normal to the plane. So now let us see how to solve this. So what we are having? So we are having a sphere x square plus y square plus z square equal to 25. So as I told you, this is nothing but a sphere whose center is at 0, 0, 0 and radius as 5. Now if you have to observe that 0, 0, 0 will satisfy the equation of the plane x plus 2y plus 2z, because when you replace x by 0, y by 0 and z by 0, it will satisfy. So we can say that the center of the sphere will lie on the plane. So what it indicates, whenever the center of the sphere lie on the plane, okay, that means what? The circle that you are going to get when you cut the sphere by a plane, that the center of the circle and the center of the radius is same. So here remember that whenever, this is a very important point, whenever the center of the sphere lie on the plane, the center of the sphere and the center of the circle is same. Another thing, the radius of the sphere and the radius of the circle is also same. Okay, and if the whatever is this radius of this circle, the same radius is there for the cylinder. So here the radius of the sphere is 5, so we can say the radius of the cylinder is also 5. Okay, so we have written that is the plane passes through the center of the sphere, so radius of the cylinder is same as the radius of the sphere. So if you look at that diagram, actually what we are having, the red part that you can observe, that is nothing but a sphere, and the darkened part that we are having in the middle, that is nothing but what, where we are cutting the sphere by a plane. Okay, so the center of the sphere and the center of the circle is same, so the radius will be same for it. So radius of the sphere is 5. So, and one more thing, so the plane that you are having, if you look at that plane, that is nothing but the darkened part. Okay, so the line which is perpendicular to that is nothing but the normal. Okay, and if you observe one more thing, that normal line is nothing but the axis of the cylinder. Okay, and we know that the drs of the normals are 1 to 2 because equation of the plane as x plus 2y plus 2z is equal to 0. So we can say that 1 to 2 are the drs of the axis, which is nothing but a normal to the plane. And also we know that one point on the axis is nothing but the 0 0 0, okay, which is the center of the sphere, and it is on that line. So we are having everything now. So let px by z be any point on the cylinder. It is as usual like the previous problem. Make a right angle triangle PMO, and here again OP square is equal to OM square plus PM square. Now I know 0 O as 0 0 0, P as x y z. I know PM is 5. Okay. Now OP square you can easily find out with the help of distance formula. OM, how to get OM? OM is nothing but the projection of OP on the axis. So drs of OP will be xyz, and drs of OP are xyz, and we know the drs of the axis as 1 to 2, so we can easily find out the direction cosines of it. It will be 1 by 3, 2 by 3, 2 by 3, and when you take the product of that, you are going to get the projection of the axis. And when you put the values of OP, PM and OM in a Pythagoras theorem, you can easily get the equation of the right circular cylinder. So mainly on a right circular cylinder, these two kinds of problems will be there. Okay, so please go through it. If you need, we will take some more examples on this. Okay, thank you for today. Bye.